about analysis of single phase AC circuit with RL load. So in RL load what we have is R and L, inductor and resistor, which will be connected with AC supply. Here we have R and here we have L. Now it's not like VR and let's say VL. Okay, so here the one thing is like which is important to notice here is, let's say VR and VL both we have. So you cannot, like, let's say for an example here you are applying 100 volt. Okay, so it would not be like a 50 volt drop here and 50 volt drop here. So if I sum up, so it is 100 volt. So it's not like the DC circuit. So if I'm thinking that there would be 100 volt in the source, so it will be like sinusoidal in the nature, AC supplies. So this 100 volt peak at that, when I have 100 volt peak at the time, 50 volt get divided into resistive elements, as well as 50 volt will get divided into inductive. So this would not be the case. If you are thinking of it, it will be wrong. Okay, so and why it is wrong, that we have to also understand. Okay, so here this resistor and inductor both are not in phase with each other. So if we just write the expression for the supply V, so it is the sum, phasor sum, if I use this word, phasor sum of resistor, voltage drop across resistor and voltage drop across inductor. Now what will be the voltage drop across resistor? It is I into R. And what is the voltage drop across inductor? It is J times I into XL. Now here if I just take common I, so this we left with J into XL. So this current is I, which is the same for you know resistor as well as inductor. So here IR and I into XL. So if I keep I common, so I will have I into R plus J into XL. So what will be the impedance of the circuit? So Z equal to V over I, which is R plus J times of XL. This is the impedance of purely RL circuit. Now in order to understand the phasor relationship, and also what will be the angle between voltage and current, and what will be the status of power factor, so in order to understand this we have to start with, so we are having two elements, one is a resistor, another is an inductor. So in a resistor, let's say the voltage across resistor is VR and current flowing through this is IR. Similarly VL and current flowing through this is IL. So the relationship would be like VR and IR, voltage and current both will be in phase with each other. And in case of inductor, what we have is VL and current would be lagging with respect to voltage by an angle of 90 degree. So 90 degree phase lag is always there. Now in series circuit, if we want to plot the phasor plot, the diagram, at the time we have to look that basically in any elements we have only two quantities, so voltage and current. So voltage will be same in case of parallel connection, and the current will be same in case of series connection. So here we have R and L, both are connected in series, so current flowing through this R and L will be the common part. So that's why in series connection I can write I, which is this current, will current, and this current equal to IR, which is equal to IL. Okay, so in order to plot the phasor plot, so I will keep this I equal to IR equal to IL. This is my reference phasor. Okay, and with, if I just look at this first phasor relationship of resistor, so IR will be in phase of lagging with respect to voltage. So now this IL is in the downward direction, but I am looking for IL into horizontal direction. So what I will do is I will rotate this phasor diagram by an 90 degree. So this VL will be here. So in order to take a phasor sum of both, I will take VL here. So VR at this and VL at 90 degree. This will gives me VZ. Okay, and the angle between two is phi. So if I just replot in the terms of VR equal to IR, this is I into XL, and this VZ is I into Z as triangle. If I just remove this I, so the reverse another triangle which I would have is this is R, this is XL, and this is Z. Okay, so let's understand this with one another example. Okay, to have a better idea of series RL circuit, let us understand with one example. Let's say the supply voltage is given as 141.11 sine 100 pi t. Now what will be the, if I compare with the standard equation, which is Vm sine omega t. So the what is Vm? Vm is 141.11 volt, and what is omega? So omega is 100 pi. I can compare those things. Okay. Next task is to what will be the impedance. So impedance we have seen as R plus J times of XL. So what is R? R is 3 ohm. J, what is XL? XL is nothing but omega into L. So this is R plus J into omega L. Now what will be the omega? So omega is nothing but 100 pi, and what is L? So L is nothing but 0.0127 Henry. So if I just multiply this, pi is 3.14. If I multiply them, I will get J 3 plus J into 4. This is my impedance. So the overall impedance which is offered by this R and L is given by this. Now there are two things. One is this is basically a complex number. In order to have magnitude, Z can be given as square root of 3 square plus 4 square, which is nothing but square root of 25, which is 5. And in order to find the angle theta, okay, this cos tan inverse of 4 by 3, because this 3 here, 4 here, and this is my theta. Theta is tan inverse of, tan theta is 4 by 3, so theta is tan inverse of 4 by 3, and if I calculate it, it will come up with 53.1 degree. Now in order to find the current, it is nothing but V over Z. And what is V? V is the supply voltage. So here my maximum value is 141.11, and what is my Z here? Z is 5. Okay, so peak value which I will get from here, this is the peak value of current. Peak value or maximum value is nothing but Vm by Z, which is 141.11 by 5. If I want to find the RMS value of current, so RMS value is Vrms divided by Z. What is Vrms? Vm by root 2 divided by Z. So Vm by root 2 is nothing but 100 volt, because here Vm is 141, so Vrms is 141.11 divided by root 2 will gives me 100 volt. So 100 volt divided by 5 is nothing but 20 ampere. So this is the RMS value of current. And in order to find the angle, so this Z is having two things. One is amplitude, which is phi, and other is the angle. So angle is 53.1 degree. So this is in denominator. When it comes to numerator, so it is minus 53.1 degree. It means that current, this is the equation for the RMS value of current, and this current is lagging because voltage is having 0 degree, and here it is having minus 53 degree. If I rewrite this expression of current of instantaneous value, so it is Im sine omega t minus theta. So it is Im, it is we have already written here 141.11 divided by 5 into sine omega t, and minus what is theta? It's 53.1 degree. So the angle between voltage and current is 53 degree. So if I am looking for a power factor of the circuit, so it is nothing but cos theta, and this is nothing but cos 53.1, gives me the value of power factor, which would come around 0.6 lagging. So in this way you can solve about series RL circuit. Thank you.